In this video, I'm going to show you how to use the chi-square.test function to perform the computations for what's known as a goodness of fit test. In a goodness of fit test, you're going to have two hypotheses, a null hypothesis that's going to give you a listing of proportions for different categories, and then you'll have hypothesized values for each one of these proportions. So in this case, I have a first proportion I'm hypothesizing is equal to 1/6. I'm having a second proportion I'm hypothesizing is equal to 2/6. And I'm having a third proportion that I'm hypothesizing is equal to 3/6. And notice they all add up to 1. And you can have as many of these as you want here. They just have to add up to 1. The alternative for this is going to be that the null is basically wrong. Somebody's not correct up there. Now, as with every other test we've had, we need to pick a significance level or a probability of a type 1 error. So I've set this to 0.1 here. And then we need some kind of a rule for rejecting our null hypothesis. So we'll just use this one here. We'll reject if our p-value is smaller than our significance level. Now, as far as a test goes, we're going to need to have a simple random sample. And then when we're done with it, we need to make sure that for everything we're comparing here, we have an expected value of at least 5. This is actually an option we can check after we perform the computations. And if it turns out that these expected values aren't all at least 5, we can just ignore the computations we did, thinking that they're wrong. Okay, so what we need is some observed values, one to go along with each one of these proportions up there. So I observed 32, 39, and 47 here. For whatever reason, those are the numbers I picked. And then I'm going to need those probabilities that I hypothesized put in a vector. And then to go ahead and perform these computations, I'm going to save them so I can look stuff up later in a variable called results. And I'll use my chi-square test, and I'm going to type in here, well, my x value is going to be my observed values, and then I need to have my probabilities typed in here. So this is going to be a p, and that's going to be equal to prob 0, and that's going to be how I go about running my test. So I can put this in, put this guy in, and I can look at my results, and I can look here and I'll get a chi-squared test statistic. I'll get some degrees of freedom, and then I will see my p-value down here. My p-value happens to be 0.006164, and if I try to apply my rule to that, if this was actually indeed real data, that's definitely smaller than the 0.01 significance level I decided upon, so this would be a case where I decide to reject my null hypothesis. Of course, I don't know if I want to believe these results until I check to see if all my assumptions have been fulfilled. And so to do that, I want to look at the structure of results and see that I can look up my expected values here. And in this case, I only have 3 of them, so it's easy to see all 3 values are at least 5 there. But I could do something like this and run that and see that they're all at least 5 in the second case. So then I know that I've sort of met my assumptions and I can trust the results that I have there. So that's how you can go about using the chi-square.test function to perform some of the calculations for this thing known as the goodness of fit test.